Hi, everyone. I'm Zuhair Khan. I'm the Director of Business Development for Vestec in Japan. We're an artificial intelligence-based company, and our focus is on using our artificial intelligence technology for speech recognition. And what this does is this actually helps us create a very significant paradigm shift in the speech industry, and I'll talk a bit more in detail about what that really means. So in the speech industry, there are really two major problems that exist, right? The first problem is that there's very poor ability to understand natural speech. What does a person mean when they speak in full sentences? So this is not a problem that you can't recognize the words that are spoken, but that you can't understand the user's intent in full natural speech, right? So that's been very poor performance on that front for the industry. And then the second problem has been that the natural speech solutions have had very high cost to implement. So if you take an expensive but poorly performing solution, then there's very little reason to use it, right? So it's just money down the toilet. Now, what the compromise has been then is that you stick to command words, right? So you sort of use single keywords, and that you can have the recognition, and then because it's a single keyword, it's easy to understand what the user wants to do, right? And then the second is then you have to navigate your menu step by step. So it's a slow and tedious process. And the end result is it's faster to just press buttons, right? And that's really been the status of the speech industry. Now, we use artificial intelligence to basically address those two big problems. Bring the cost down very significantly and improve the accuracy when you're talking about natural speech solutions. Okay. So why do these problems exist? The number one reason is that the existing methodology for handling natural speech has been brute force pattern matching. Okay? So you gather a large database of all the different ways a person can speak. Your system, in essence, sort of does rote memorization. If a person says this particular pattern, this is what it means, this is the action the device needs to take, right? There's no understanding. It's just brute force memorization and pattern matching, right? So that means you have very high costs. You have to gather all the patterns. Now, the second part, and that's on the understanding side, but even before then, there's a problem when you're decoding your speech, when you're converting the speech to text, right? So you have a waveform that's coming in, you have to convert it into text. Even that decoding of the waveform is done sequentially. And it's done sequentially to be able to, and in order to do that, you have to have a good guess of what the person is likely to be saying, what word is likely to follow the next word, right? So you need those patterns. And if you talk about even a very simple task, like you want to order a Coca-Cola, you look at the number of different ways in natural speech. If somebody is in a restaurant and they want to order a Coke, I mean, they'll say, I want a drink, Coca-Cola, please. I'm thirsty, please give me a Coke. My throat is dry, I want a Coke. I mean, there are 1,000 different ways you can just do that one task, which means if you're doing brute force pattern matching, you need to gather thousands of pieces of data on that pattern. And even then, there'll be new patterns which don't match, right? And in this, when you're doing the decoding of the speech, if you get any words wrong, because you're starting from here and you're decoding this way, so you make a mistake somewhere along the way, and then you want to try to match this up against your patterns to say, what does this mean? And you've got a wrong word in there. It all breaks down, right? And so that's why there have been big problems with this. And then you have the problem where you have people like Yoda, who doesn't speak in your regular patterns, right? So he would say, drink want I, or thirsty I am, dry is my throat, right? So you have a speaker like this, and suddenly everything you've done, all the thousands of patterns you've gathered are thrown out the window. And I mean, this seems whimsical, but when you have non-native speakers, you'll often have these type of grammatical structures in there. And actually, when people speak, you rarely use the same way of saying the same sentence twice. I mean, every time we speak, we say things a completely different way, right? So this is the problem. And one of the things that when you look at the reasons for why a system is not able to correctly interpret natural speech, the number one reason for getting things wrong is that the pattern in which the person speaks is different from the pattern in your training data that you've gathered. So people think that it's that you can't recognize the words. No, you'll get all the words right. But the pattern is just different. The ordering is different. And that messes the system up. So that's the number one reason. The number two reason is that you have slight variations in words within it. So in your original data, in your database that you trained on, you may use the word cancel. And then when the user is speaking, the word ordering is the same, but instead of cancel, they say canceled, or cancels, or cancellation. So there's a slight change in that word, and that'll throw the system off as well, right? Now, for Vestec, the way we do things is quite different, and both of those two reasons really aren't a problem for the way we do it, and that's why we have much higher accuracy. Okay. Now, to explain what we do, our way of approaching speech understanding is much more similar to the way a human goes about it. Okay? And think about if you have studied a foreign language. When you study a foreign language, and you try to listen in on conversations and try to understand what people are saying, you focus on two things. Your vocabulary is somewhat limited, so you try to focus in not on every single word and getting it right and parsing the grammar, to minute detail. No. What you do is you try to look for the words that you understand and that you know, and that have meaning that's important to you, right? And then you look at the overall context of the conversation. So based on the context of the conversation, the words you pick up, and the relationship between those words, then you make your guess about what is the person saying, right? And usually it can work pretty well. So Vestec's methodology is similar to that. It's the way we actually do process language. When you listen to somebody speaking, you're not parsing every word in the grammar in minute detail. You only bother to do that when the sentence is overly complex and doesn't make sense in an obvious way, right? So most of the time, this works very, very well. And you can see that this is a very low-cost sort of system, and actually it has much better performance than much more complex rule-based systems. Now, if you look at most natural language processing systems, they actually came from text processing, right? Now, when people write, people tend to follow grammatical rules, right? Because you write it, you edit it, you rewrite it, you tend to follow grammatical rules. But when you speak, all that goes out the window, and you say all sorts of half sentences, and half gibberish clauses, and you throw in lots of strange words like and like, and pauses and strange things, right? So that's why Vestec's type of system works very well with speech. Now, there's a lot of different types of AI technology in the soft computing domain that we use to actually have algorithms to be able to understand and interpret these things. Things like fuzzy inferencing, neural networks, and a lot of sort of self-learning algorithms. Now, to give you an idea of how we would parse certain sentences, right? So this is in a banking application. So here you already understand the context, right? So that's the starting point. And let's say you have to define a couple of concepts, and there are many different ways that you can talk about that concept. So one concept is the word balance, right? So in a banking application, you want to know the balance for your various accounts, right? And the word balance, you can say it in different ways. You can say amount, funds, total, money, dollars, how much, X number of different synonyms or ways of saying that you want to know the balance. And the other part you need to know is, for what account do you need to know the balance, right? So if you take this sentence over here, the person says, I need to know available funds in my savings account right now. Now, if you look at it and you look at the second sentence, the words that are really important in this case are basically the word funds, or it could be available funds, and the word savings, right? And all the other words, I need to know, in my, right now, they actually don't change the meaning of the sentence, right? So you get the word funds, you get the word savings, you have two concepts, you understand the relationship, and you understand the context of the application, and you can understand that funds here is equivalent to balance, and savings means your savings account, and you know what you need to return. You need to return the balance of the savings account, right? Okay. So what is the implication of this? In a traditional system for handling natural speech, what happens is, if you look at even quite basic applications, a typical person, when they speak, they'll use about 5,000 different words. So if you want to do a full transcription and a rules-based parsing, or you want to do that full brute force pattern matching, first you need to know what are those 5,000 approximate words that a person is going to use in that given application. So you have to build this 5,000 word grammar. Second, you need to know what are all the different patterns in which they'll talk about the specific things that can be done within that application. Those could average easily 50,000 different patterns. So you gather all of that data, and that's your starting point for a natural speech system. Compared to that, using Vestec's approach, where you're focused in on what are the words that really have meaning and everything else, you have a system of tagging and removing, then the patterns really don't matter, right? The words may be reduced down to something as little as 200 words. And everything else is handled by our AI-based garbage model. And the garbage model's job is to basically pick up the other words which are not important, tag them, and remove them, right? So you're down to really the core words, and you tag and remove everything else. And it's very easy to see the cost of doing this is a lot less than the cost of doing that. And actually, the cost savings can be 80% or so, right? And the time saving is similarly huge. So you can do a natural speech for, let's say, approximately 1/5 the cost that you would have to do it under the traditional systems. Now, Vestec can also do natural language speech in a manner that's similar to traditional systems, in the sense that we use speech pattern data, but we use it very, very differently. Okay? So this is an example of a kiosk for automated payments, right? And in this kiosk example, you can make 3 types of payment. You can pay for concert tickets, you can pay utility bills, or you can pay for buying video games, right? So what would you do in a natural speech application? How would you develop it? Well, in a typical methodology, you would have thousands or tens of thousands of speech patterns, right, of what people might say. So I need to buy a Bon Jovi ticket, right? And then you need to tag, what does this mean? This particular sentence is then tagged as concert payment, right? Then you have another sentence. I'm sorry, but I'm in a hurry. I just want to pay my electricity bill. And you need to tag this. This is a utility payment, right? And so for those tens of thousands of different speech patterns, you would have all the different sentences that people would say, and then you'd have tagged what does that mean, right? And then in a typical system, you would brute force pattern match it. So when a user comes and he says something very similar to a pattern, you'd say, okay, this is the closest match, that's what it means. Or if there is no close match, the system would just reject it and say, I don't know what you said. Even though you might be able to have a full exact transcript of what the person said, but it doesn't match one of your patterns in your database, right? Now what Vestec does is, when we use this data, what we'll actually do is our AI system will automatically extract what are the words which have meaning in this, and what are the words which are irrelevant. So it would, in this kind of example, pick up words like buy, pay, get, all these sort of words saying that you need to make a payment. And it would extract words for the different types of items that you could make a payment for. So for example, Bon Jovi and ticket, it'll know that these words are related to concert, right? And then you'll have words like electricity or bill or gas, phone, whatever. These would be related to utilities, right? And then you'd have words like game, PlayStation, Final Fantasy, blah, 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 which would be related to video game payment, right? And once we've extracted these words, then we can generalize the logic that when you have payment words together with certain words related to these different concepts, then you can understand what those are related to, right? So it's not brute force pattern matching. It's saying, have you said words which are relevant to a particular action, and the AI will understand that in that context, right? So if the patterns change completely, but as long as you've picked up the relevant words and you know the context, our system can operate. And that's why the patterns don't matter. And that's why small changes in these words don't matter, right? So in the earlier example, I said cancel, canceled, cancellation, cancels. As far as Vestec's system is concerned, those words all have the same meaning. Actually, let me say one more thing about this. In the typical traditional speech systems, when you gather all this data for all the various patterns, right? Usually it's somebody working part-time who'll do it and who'll do this tagging, right? Because it's tens of thousands, so you hire somebody cheap to do this. And very often when you look at the data will be a mess. So you'll have a lot of mistags. And if you're doing brute force pattern matching, if the original data is mistagged, when the system runs, it'll actually give you the wrong end result because somebody made a mistake in the original tagging. In Vestec's system, what Vestec will do is once you've run the data through it, our system will then actually do a logic check that does the tag of all your data match the generalized logic that it's developed, right? So for example, let's say the first one was tagged, I need to buy a Bon Jovi ticket, and the part-time person who did the tagging had written over here utility payment. Our system would actually highlight this and say there is no word in here indicating this is anything to do with utility. It would say this looks to it like a concert payment thing, because everywhere else where the word ticket is used, it was related to a concert. Or where the word Bon Jovi was used, it was related to a concert. And the system will actually help you clean up the data. And this would be done on an automated basis. So when you have cleaner training data, you have a much better system, right? So the end result of using Vestec's system is for a where we don't even need any data on the speech patterns, just what are the words that are important in that context, the cost can be 60 to 80% lower than a traditional natural speech system to develop. The time to develop the system can be 60 to 80% less. And you'll have better accuracy and a better customer experience, right? And I'll actually talk a lot more about why the customer experience is actually better in Vestec's system, because in Vestec's system, the outright rejection of something that a user says is much, much lower. And if we were to use data, the cost savings go down a bit because if we have to gather all the data, but it'll still be around 50%, 40, 50% cost savings minimum, even in a type of system where you need to gather data. And that does become necessary when you have very complex logic, because you need data to train a system when you have very complex logic that the system needs to learn. Now, here's an example of an airline information system, okay? So, in your typical sort of airline information system where let's say you use a DTMF menu, you come to the top and the system would say, so-and-so airlines, please press 1 for reservations, or say the word reservation, press 2 for flight information, or say the word information, press 3 for mileage, or say mileage, press 4 for lost baggage, or say baggage, right? And then let's say you either press 2 or you say the word information, and then it'll say, okay, press 1 for arrivals, or say arrival, press 2 for departure, say departure, and you would navigate the menu that way. Basically, with a DTMF type of menu where you can just replace it with command words, right? Now, using the natural speech system, you can navigate the menu tree in one shot. So where the user can say, the system would prompt, XYZ airline, how can I help you? And then you say, okay, what time is the flight from Singapore arriving today? Now, how would Vestec's system handle this? What it would do is it would pick up different words related to different concepts, right? So the first thing and in this type of scenario, it needs 4 pieces of information, right? So where it picks up the word time or what time, that tells it that this is a flight information query, right? What time isn't related to a baggage query. And then it'll pick up the word from or arriving. And these words indicate that this is about an arrivals. The word Singapore tells it where it's coming from, and then today tells it the date. And extracting those 4 pieces of information, the system could then respond with the status of that flight. What time is it arriving, right? Now, again, in a typical IVR type system, from here you would have to start, sort of either pressing 9 or some button to go back up the menu for your next query, or you have to say the word back, 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 or something like that, right? However, with a natural speech system, what would happen is the system could then, after it's responded to your first question, it would just reprompt you. How can I help you? And now maybe you want to know your departure flight information. And so you just say, I want to know the departure time of the Hong Kong flight on Monday the 19th, right? It again picks up information on those 4 concepts. So it says, okay, this is time, so this is a flight information inquiry, departure, so it's related to departures, it's for Hong Kong, and it's on Monday the 19th, right? It gets the 4 pieces of information and responds. Okay. Now, the next thing then is, what if you don't give sufficient information, right? So what if you say, what time is the Singapore flight today? It's very similar to the earlier sentence, but if you look at it, you realize that it doesn't tell you anything about whether this is arrivals or departures, right? So what the system would do is it picks up 3 pieces of information here. What time, so it's a flight inquiry, Singapore, and today. But it's missing words about arrivals or departures, and so it'll just talk back to you and ask you, is this for departing flight or arriving flight? Right? And a typical speech system, if you don't have this exact type of sentence in your training data and tag to say, in this case, this is how you need to talk back, the system would either just reject it, or it would randomly say, either give you arrival or departure or some information on whatever it thinks is a close enough match. Okay. We can also do this in a form-filling type of function. So where you say, well, this is a pizza ordering example. I would like to order 3 large mushroom pizzas at this time. And our natural speech system could then pick up the relevant words and start filling in slots, right? So what type of food do you want? A pizza, quantity 3, size large, type mushroom. And this can be used to execute all sorts of business processes. Okay. We offer our systems currently in 10 languages, and we're coming out with 5 more languages immediately in the next 2 months or so, and then early part of next year. And this will let us cover 25 of the 30 biggest economies in the world, and then after that we'll continue to build out our global coverage. So we can basically support the Asterisk community around the world. Okay. Now, the advantages to users of our system, first is you have 10 to 20% higher accuracy when you're handling natural speech systems, right? And basically, your cost of developing this is about 1/3 of what it would traditionally cost you to do a natural speech system, which means you can do natural speech for the cost of what would traditionally be for command word-based speech systems, right? And the advantage is there's no hierarchical menu to navigate. You can do all sorts of one-shot navigation. You don't have to remember the command words. You can say things in free form in many different ways. You don't have to read manuals, et cetera, for the end user, right? Now what I'd like to do is show you a quick demo of our system. So this is an example of the flight information system I said, and we just did this for an airline in China. So their hub is in Shanghai. And you can have flights, to or from America, Asia, Europe. In America, sorry, you can't really read it, but it says New York or San Francisco. In Asia, you can have flights for Bangkok or Singapore, Europe, London, or Paris, right? So this is a subset of their flight schedule. And then you can have arrivals or departures for each of those destinations. And then below that, what it is morning, afternoon, evening, or night for the flight, right? So now in your normal, natural, let's say step-by-step, keyword-based speech system, what would happen is you would sort of say, single words, right? So here you'd say, okay, America.